Welcome to the Tom Nelson podcast. Today I have Ross McKitrick here. And Ross, could you go ahead and just tell us a little bit about yourself to get things started?
Sure. I'm a professor of economics at the University of Guelph here in Canada. I have a PhD in economics from the University of British Columbia, and I've been working for about 25 years now on climate change and environmental economics. And in addition to doing work on the economics of climate change and environmental policy, because I have a lot of background in econometrics, which is what we call the applied statistics branch of economics. I've ended up doing a lot of work on some physical science topics as well, looking at the statistical analysis side of things. So I've done a lot of publications in climate science journals on things like temperature trend analysis and climate model evaluation, and lots of topics, including malaria transmission and things like that, as well, like I say, as all the economic policy analysis.
Okay. And you were involved in the climate debate well before Steve McIntyre was, right?
Yeah, I'd been writing about the Kyoto Protocol issues around Canada, trying to comply with the Kyoto Protocol. This would have been starting in the late 90s, early part of the last decade. And Steve started working on the hockey stick stuff around 2002, and he contacted me in 2003, and that's when we began to collaborate. And he'd reached out to me because he'd seen me in the press talking about the Kyoto Protocol.
Yeah, I'm very interested in hearing about what that was like there in those years, right when you were working with Steve McIntyre on the hockey stick, and what was that like, or what can you share about that?
Well, I'd seen some postings that Steve made on a discussion board, and I found them intriguing. I'd looked at the hockey stick paper myself and saw that it was based on regression analysis and principal component analysis, which are two tools that we use in econometrics. So in principle, I understood the methods, although I didn't work through the details of how man put the whole thing together. And here was this guy. I didn't really know much about him, but he seemed to have deciphered the math and worked out a bit of a replication. And then he contacted me and sent me all these notes that he'd written up. And I thought, this is actually really important. What he's finding some problems in the data and some difficulties trying to replicate the results. And so I agreed to help him write it up for publication. And so that was heading into the fall of 2003. We got the first paper out where we challenged the results and said some of the data series don't match the sources. We can't actually figure out what all the data was that went into this and how the various series were truncated and joined together, and also the principal component results. We couldn't replicate those. And these seem to be influential problems for the results of the paper. That was the spark for the whole controversy that erupted at that point. And there was a few months in late 2003, it was very intense, a lot of back and forth, emails back and forth, Mann and his group, very hostile about what we'd been doing and not forthcoming with details about where our results differed from theirs. And we pursued into 2004. Once we were able to narrow down a specific issue around how the principal components were done, and for people who might remember the details of this, the issue is an error in Mann's program for calculating principal components. That normally, if you're going to, this is a type of analysis where you could take a whole matrix of data and extract one or two columns. You can think of them as like averages, one or two types of averages that try to summarize everything that's going on in the matrix, but in a much smaller set of data. And the first thing you have to do with principal component analysis is subtract the mean of every column of data, put everything on a zero mean. And he didn't do that. He subtracted the mean of the last portion of the data set. And So it meant he wasn't calculating proper principal components, and that particular mistake meant that all the weight got added to a handful of series that had an upward trend in the 20th century. And so it created a distorted shape in the principal components, which then distorted the shape of the final result. So we got a paper published in Geophysical Research Letters in 2005, along with another paper published in Environment and Energy, going into a lot more detail about data issues. And at that point, fully reconciling what we'd initially done and what man had done, and accounting for all the differences and all the things that we chalked up to errors, things that we said these poor data choices. And then 2006, that was when the National Academy of Sciences panel was put together. Oh, backing up a step, I think it was 2004, we'd submitted a complaint to Nature magazine about the hockey stick paper, that saying the data set wasn't properly described, the methods weren't properly described, you can't reproduce the results. And also he hadn't reported verification statistics, these R-squared scores for his reconstruction. He'd left most of them out of the paper. And so Nature ordered Mann and his co-authors to publish a core agendum. They had to put a new data archive together and a more accurate statement of their methods. They didn't end up releasing the R-squared scores. They came out indirectly later on when another pair of authors, Wall and Amon, who were entering the debate trying to defend Mann's original method, and they replicated his results in another paper. And as part of the review process, because Steve was a reviewer, he insisted, okay, well, then show us the R-squared scores. And so they included in that paper a table of the R-squared scores that weren't, and I'm sorry for your listeners, I'm using some jargon. R-squared is one of the statistics that's used in a statistical model to assess the quality of the fit. And so if you have an R-squared score close to 0, it means your model doesn't really explain anything, and it's just noise. And so the Wall and Amon paper, they were ordered to include the table of R-squared scores. They came out and showed that Steve had been correct in his calculations, that once you go earlier than the year 1700, the hockey stick had no information in it. It had an R-squared score that was statistically insignificant. It was close to 0. So that would have been around 2005, I think that came out. And then, like I say, 2006, the National Academy of Sciences report came out. And we found all the points that we made were upheld in the report. They agreed the principal component method was defective. It distorted the results. This group of proxy records, the bristlecone pines, that were really the only source of the hockey stick shape. It was just a set of proxy records from a single region in the United States, that the original authors had said, these are not reliable temperature proxies. You shouldn't use them in a climate reconstruction, because the 20th century slope they thought had more to do with CO2 fertilization than temperatures. The NAS panel agreed the bristlecone pine records shouldn't be used in temperature reconstructions.
So just a little question here. Did they have actual temperature data from thermometers from the same area so that they could kind of compare that against the bristlecone pines and find out that it was not matching, right?
Yes. So they could look at that region and say, we don't see a corresponding temperature trend here. So something else caused this uptick in the ring widths. Ironically, that paper by two authors, Graybill and Idso, the Idso being Sherwood Idso, who was famous in the history of climate skeptics as sort of the grandfather of the climate skeptic movement, and he did a lot of work on CO2 fertilization, so I think it's quite ironic that his data set ends up reappearing years later with a different label on it, making it look like this is a temperature reconstruction of the Northern Hemisphere and being used to promote the climate alarm. anyway, the finishing up the story, I guess around 2006, there were hearings in Congress. The NAS report came out. The NAS report, while it agreed with all of our criticisms against man's methods and results, they also included discussion of other studies where they said, but these other studies have roughly come to the same conclusion. So we're willing to endorse the idea that back to about 1400 20th century temperatures are unprecedented. They didn't dive into those other studies to see that they weren't actually independent of the hockey stick, because they're using many of the same proxy series, and in some cases reusing the same flawed principal component methods. So we weren't happy about that part of it. But that whole episode kind of came to an end with some hearings in Congress, and all this material basically came out. And then from that point on, the latter part of the last decade, Steve kept working for quite a while on proxy reconstruction studies. He blogged about it at Climate Audit quite extensively. He and I collaborated, shared notes on things, but let's see, we had one other paper in Proceedings of the National Academy of Sciences where we critiqued something else that man had published, and argued one of his key proxy series, he misinterpreted it, and that affected his results. But then we kind of went off in different directions at that point, stayed in touch. But Steve stayed with the proxy materials up until a few years ago. And I've since been going on to work more on temperature data quality and climate model validation, and some of the econometric topics around that. And I haven't really been involved in paleoclimate side now for about a decade.
Do you have any sense of what really was going on in the paleo world in terms of they didn't have people who really understood how to do the statistics correctly, or did they really want to get one answer so badly that they just did anything they could to get the answer and throw out the statistical correctness? Or what do you think was going on there?
I think if you approach the literature with both of those statements as prior assumptions, you won't really find strong refutation for either of them. There is a sense of it's sort of a cottage industry to see who can make the most dramatic hockey stick and extend it farther back in time. The papers that come out that they can use perfectly sound, valid methods and show a medieval warm period comparable to the present, they have a rough go getting into print. They'll end up in print, but in lesser known background journals. Papers that have a flat hockey stick handle and a sharp 20th century blade, they're going to get into the best journals, and it won't really matter what methods they use. They're just, I think there's the issue there of confirmation bias, and also just journals like the results that they know are going to get a lot of publicity and attention in the IPCC reports. The issue around statistical methodology is also acute, because some of these things are standard in econometrics. Well, I mentioned that it involves regression analysis. So that's a standard tool in econometrics. I mean, to do a PhD in economics, you're going to take probably 4 courses at a minimum in regression analysis. And then along the way, you realize that it's very easy to get deceptive, incorrect answers using regression methods. You have to learn how to test your results properly. And so there's a big difference between what you'd see in an economics journal when they present a regression model that is then used for out of sample projections, all the testing that goes into it to make sure that you've got reasonable inferences, versus what you see in the paleoclimate field, where a model is run and then they just generate out of sample projections without doing the same kind of testing. And the end result is that I just became kind of cynical about all of those papers that came out. I can understand how you can generate these hockey stick handles. It's more the error bars they put around them. Those are it's very difficult to do correctly, those kinds of error bars. And most of the mistakes that you can make in regression analysis lead to underestimating the uncertainties. And once you start to fix some of these, what you end up with is you might still have a hockey stick shape, but you have error bars that basically go from minus infinity to plus infinity. And so what the data is really telling you is you just don't have information that far back. And there was a very good paper years ago, I don't know now, but between 5 and 10 years ago in the Annals of Applied Statistics by two statisticians, McShane and Weiner were their names. And they were outsiders to the field like Steve and I were. But they went in, took some of the standard data sets, and they just said, okay, if we use standard statistical forecasting methods here, you've got a small sample where you have the proxy data and the temperature data together. That's where you fit your model. And then you're going to make these projections back in time using just the proxy data. And with minor variations in the model during the overlap period, you get completely different profiles of what happened in history, including you can have a really hot medieval warm period or a cold medieval warm period or something in between. And there isn't enough information in the fitting period, the overlap period, to distinguish those models. So sure, you can pick one of them and publish it and generate error bars around it. But that's not really telling the reader about the full dimension of the uncertainty here. Just there's so short a period of overlap between temperatures and proxy indicators. And within that period, there are so many mismatches. I mean, that was the Climategate issue. The big revelation there, the whole hide the decline episode, was related to the fact that there's a big proxy library that starting at 1960, it starts going down while the temperatures that are supposed to match it start going up. And so over a 3-decade interval, they diverge. And here again is another topic where in the field, and this came up at the National Academy of Science hearings, people started to ask questions. Well, what about the divergence problem? What's that? And this confirmation bias kicked in, like hearing them talk about it, where on the issue there is the proxy measures for a period where you've got the proxy data and the temperature data, they don't match at all. There's no reason to think these proxies are telling you anything at all about temperatures, because you can plot the two on a chart and one's going down and one's going up. So what makes you think that the same proxy data is informative for what happened in the 1400s or the 1200s? It's useless today. So why would it be informative back then? Well, they came up with all kinds of ad hoc explanations. They said, oh, well, it's something to do with ozone depletion or, air pollution today, but that wasn't an issue back then. So it must have been valid back then. And in the hide the decline episode in Climategate, what happened there was in the preparation of the IPCC report at the time, they showed the proxy data and everybody could see that this messes up this story that their proxy models are good for generating paleoclimate histories of the world. And so the solution they came up with was we'll just chop out the post-1960 part of the proxies and only show the thermometer data and smooth it all so that you can't tell what we did. And then they got this nice diagram that was in the IPCC report, and then it went on the cover of a World Meteorological Organization report that was sent to governments around the world. And it was a very compelling diagram because it looked like all the data sets agree. It looked like all the proxy measures, all the thermometer measures all agree perfectly, because look at how smoothly they all line up. But what they didn't explain was, well, it's because we chopped out all the stuff that doesn't agree and we smoothed over the splice. So that was a big scandal, and on the more technical side, as I mentioned, this McShane and Weiner paper, where they picked up on the fact that these data sets don't fit together all that well during the interval where we have both thermometers and proxy measures. And so they're just not informative as you go back in time. And so there was enough, I thought that point was well enough established that I kind of lost interest in the subject at that point. I'm getting more and more outside of my own area of economics, so it's harder for me to sustain an interest in it. But just the feeling that the data aren't informative going that far back in time. I can accept very local reconstructions where you've got a really good match. If you've got a good proxy library for one geographical region and good quality temperature data over 100 years, and you can show that, okay, there's a low frequency and high frequency match here, then I think those are valuable. Typically, they don't show much exciting though. They'll show, well, precipitation's gone up and down, but it hasn't changed much. Even temperatures haven't changed much. Sometimes they're up, sometimes they're down. But it's these hemispheric reconstructions and global reconstructions where people are taking spotty little samples of proxies around the world, and then, you know, with 15 locations, they're now going to reconstruct the temperatures in the 1300s. That sort of stuff. At a certain point, I thought, all right, you guys, if I don't believe it, if you guys want to believe it among yourselves, go for it. But I just don't put any weight on those kinds of studies now.
And you talked about the tree ring divergence. And then when you're saying proxies, are you skeptical of all other types of proxies, whatever else they're using, not tree rings, but sediments or whatever? What do you think of those?
I don't have a professional opinion about them. I mean, I'm agnostic about them all. I think with proxies, there's always a bit of hand waving, even tree rings. You know, what is it really measuring? And then you have to show that it fits the data. And then, another trick they do is what they call pre-screening. And this one, so they'll take 100 proxy measures, and then they've got one temperature data that they want to fit. And then they check the correlations between all the proxies. It might be a library of tree rings or something. Check the correlations. Most of the correlations will be zero. There won't be any fit. So then they throw those out of the data set, and they only use the handful that appear to have a fit, and they call it pre-screening. And there are various ways of trying to defend this practice, but it's cherry picking. And if you're going to do that, at the very least, you need to then adjust your confidence intervals for the fact that you have done that cherry picking. And again, the adjustment to the confidence intervals would make them extremely wide, so that because you can think of it that if you just generate 100 columns of random numbers, there's going to be a 5% chance that one of them will have a significant correlation with whatever target series you're interested in, just the nature of random numbers. So if you find 5 out of 100 of your proxies match your temperature data, it doesn't let you then pick those 5 and say, well, they're informative. Really, the fact that you had to throw out most of the data should tell you these proxies aren't very good quality. But the whole practice of pre-screening is another reason that I just thought it's hard to take seriously any of these results. And maybe out of the, I don't know, dozens and dozens of these papers that get published every year, a few of them are solid and a few of them are reliable. The problem is you have to dig through so much bad methodology to find what might be 1 or 2 reliable ones. Again, it ceases to be interesting after a while.
Okay. So for me as an outsider to the statistics, it makes more sense to try to, when we're trying to figure out how warm it was in the medieval warm period, to try to just use records that we have, or where did they grow grapes, or do we find tree stumps that have been carbon dated 5,000 years old that are north of the current tree line? That type of evidence means more to me than trying to figure out these stats. I don't know if you agree with that at all, or.
Yeah, I do agree with that. Yeah, there are certain indicators. For instance, in northern Quebec, there's fossilized remains of, or I guess not fossilized, but remains of forests that grew far north of the current tree line, up in the Arctic tundra, that can be dated to 500 to 1,000 years ago. And that to me is just a very objective piece of information, that for a long period of time, northern Quebec was much warmer than it is now, because at this point, forests can't grow there. It's too cold. And but it would only have been in the 1500s that the last of those forests burned. The forest fire wiped it out, and then nothing could get reestablished because the climate had changed. So those kinds of studies, and also mountainsides, as you've alluded to, where you find tree stumps 1,000 years old above the current tree line. Well, it's a secure inference that then those trees could grow back then, if they can't grow today because it's too cold or too dry or whatever. So I think those are much more reliable than the attempt to match all the wiggles in proxy evidence. And again, as I even find, so they do occasionally read some of these reconstructions. If it's a local reconstruction, if it's just one little patch of real estate, and they've got a good match without cherry picking, with a proxy and a temperature series, and they can explain it on biological grounds, then I think that's as good as we're going to get with these kinds of historical reconstructions. But you can't do a global reconstruction with a dozen sites around the world, where you, especially when you're starting with having cherry picked the underlying studies. There, it's whatever reconstruction you get, I just don't believe the error bars on it. I think they're way too small.
So in going through the whole hockey stick battle, was that an eye-opener to you about how science works and how the stuff really hadn't been peer-reviewed or hadn't been really checked? When Steve McIntyre asked for the data, they acted like nobody had ever asked for it before, right? Was that a surprise?
No, I wasn't surprised. I think
Okay.
Steve was more surprised than me. Having been in academia long enough, I knew that it's very rare when a journal article is submitted, an empirical paper. That's pretty unusual, or especially back then, it would have been very unusual for anyone to ask to see the data and to replicate any of the calculations. It's a fairly recent phenomenon that journals now insist on submission of the data and the code, and nowadays it's not even enough to say we'll make the data and code available after publication. You have to post it on a public archive like Mendeley at the time of submission now. And some of the economics journals around the middle of the last decade, they began imposing replicability requirements, meaning authors had to submit data and code or send it to the journal or somehow make it available. Doesn't mean the referees will necessarily try to replicate everything, but when Steve and I were working on these things, and we could tell, as you say, when Steve asked Mann for his data back in early 2003, I think it was, and Mann's reply was something to the effect of, well, we don't have it all in one place. I'm not quite sure where it is. I'll ask my associate to try to put it together. And Steve, coming at it from a business background, just thought, well, that's ridiculous. I mean, how can I be the first person who's ever asked you for this? Your paper was in a peer-reviewed journal. It was in Nature magazine. I thought that's sort of the cream of the crop as far as stringency of peer review. And governments around the world have used this graph. It's been in reports. It's been promoted all over the place. How can I be the first one to ask to see the data? But I think he was. And the reviewers at Nature would not have looked at the data. I'm not convinced Mann's co-authors even looked at the data. And so, yeah, like I say, I wasn't particularly surprised, but because that was par for the course at the time, and in some ways it still is. But for Steve, his background was more thinking about audits and the kind of requirements on a business, people in business, even for small scale transactions, the disclosure required. And he just assumed that academia would be more stringent, but it turned out to be the opposite.
So you think maybe Bradley and Hughes, they were the co-authors, right? That they may not have looked at the data. Do you think were their names just put on there, or what did they do if they weren't even looking at the data?
Here I'm just speculating, but
Yeah.
in the various correspondence that came out and things that we saw afterwards, it just didn't sound like they were addressing any of the detailed issues with specific knowledge of the raw data sets involved, how they were processed, how the principal components were spliced together. Any of those things, I think they, Mann did all of that, and he reported back to them, and they probably, given their specific backgrounds, I think they were more interested in the nature of the Proxy archives, where to look for data, and some of the calculations, some of the test statistics, for instance. I think they'd be familiar with things like the R-squared score and the RE score, but they didn't do the calculations themselves. There wasn't any point in all of that controversy where Bradley and Hughes weighed in independently with any of the information, including at the National Academy of Sciences hearings. It was all Mann himself in the discussion.
It must have been pretty interesting for you to look through the Climategate emails then after the fact and see what was happening on the other side. Did you enjoy that?
It was. I wouldn't say I enjoyed it. It was. I mean, it was stressful to go through the first time, and then going through it afterwards. Some of it didn't surprise me particularly because you're on the other side of the conversation. Some of the things that were going on in the background. I would say there was the enjoyment came from the sense of, okay, there are things that we suspected. Now we see in black and white this really happened. So, for instance, the role of senior people at the IPCC in the whole Hide the Decline episode, that really came out clearly in the Climategate emails, where you saw, all right, they knew the proxy data contradicted the message that they wanted to send, and they were getting pressure from the government levels and from the leadership of the IPCC for what they called a nice, tidy story. And that got passed down to the rating team, and there they had a willing accomplice, or a few willing accomplices on the rating team, who were willing to justify to themselves why they should just go ahead and chop out the data that contradicts the nice, tidy story. The other things, though, like the review process, having gone through the process of trying to get the IPCC to acknowledge flaws in their temperature data, the surface temperature record, and being very closely involved in reviewing the IPCC draft, criticizing what was there, and seeing this conflict of interest. You got Phil Jones as the lead author for that section of the IPCC report, where they're going to rely heavily on a data set constructed by Phil Jones, and they're asking Phil Jones to review the comments of critics of the work of Phil Jones. And then you wonder how that's going to play out. Well, Phil Jones comes out on top. And so when he made up this claim that results that I'd published were statistically insignificant, and that went into the IPCC report. And that one, I mean, my jaw just dropped. I knew the IPCC works to a foregone conclusion, but here they were just making stuff up. And then it was, well, it took a few years, multiple publications, but also in the aftermath of the Climategate emails, the UK government set up a few inquiries. And so there was the Oxford inquiry, which wasn't an inquiry at all. It was really just a quick coat of whitewash on the CRU to let them get back to work. But the Muir-Russell panel was a more detailed inquiry. It was still set up to protect the establishment and put the whole issue to rest. But one of the points, I submitted about 90 pages of evidence to them, and they had to deal with certain issues that I knew they would rather not have to deal with. And one of them was this claim in the IPCC report by Phil Jones that my results, which showed that his data set is contaminated with things like urbanization bias and other land use change patterns that introduce a warming bias in the land record, and that his supposed filtering system doesn't actually get rid of any of that stuff. And his claim was my results were statistically insignificant, which was untrue. And anyone who looked at the papers could see the results were statistically significant. So I asked the Muir Russell people, I knew they're going to interview Jones. What's the proof of this statement? Give us the, in statistics, we would say, what's the p-value of your test statistic here? And it didn't end up in the report, but I found some of the background transcripts of the interviews. His reply to that was something to the effect of, you don't need a p-value for a statement based on the laws of physics. And which is quite a pathetic dodge, because we're not talking here about the law of gravity or something like that. We're talking about empirical patterns in noisy data sets, and that's, you absolutely do need a p-value to make a statement about that. But they let it go, and they had some mealy-mouthed wording around this issue. Just came down to it was something to the effect of, well, the IPCC reports an assessment, and so the authors of each chapter have to weigh conflicting evidence and offer their professional assessment of it, and that's what happened in this instance. And then they didn't seem bothered by the fact that the conflict of interest here is that Phil Jones was the assessor, comparing his work to that of his critic, and he shouldn't have been the one to make the call on that. Now, in the follow-on report, the AR5, the fifth assessment report, in the chapter there on surface temperature data sets, they backed down. They said, okay, what was said in the previous assessment report, there was no specific evidence for it, which was their polite way of saying, we made it up. And going through the subsequent publications, they did conclude that McKitrick and his co-author had shown that there's significant contamination of the record. So in that sense, it was a vindication. But having said that, they go ahead and use the data anyway. It's almost as if they'd fought this point for a long time. Oh, no, there's no contamination of the data. We're no warming biases here. We're not worried about it. And then they finally say, yeah, okay, there's significant contamination of the data, but we'll use it anyway and ignore the problem. So that's sort of where that issue ended up. And I'm not sure, again, there's so much confirmation bias. There's such a strong need for certain things to be true in that field that I don't know at this point how much more evidence it would take for them to admit that the land record, especially in the Northern Hemisphere, well, even the Southern Hemisphere as well, the land record just isn't a very good tool for precise measurement of climate warming, that you should take it for granted that there's a warming bias in a lot of these records because of where the data is coming from. And data coming from airports in the Southern Hemisphere, where most of the Southern Hemisphere land record comes from, the prima facie assumption should be there's probably a warming bias in this. And a warming bias would be very hard to quantify and remove. But anyway, like I say, I sort of got to the point there where I thought, all right, if what I and others have published on this isn't enough to convince them to admit the problem, then nothing is going to shake them loose from these assumptions.
So do you have any sort of a rough estimate of how much of the warming since 1850 that they're telling us has happened? How much of that could be explained by UHI or urban heat island?
Well, in the papers that I published, we did put in some quantitative estimates, but that was work that was done using data that was available up to the early part of the last decade. I think there's better data now, and it's one of the things I'd like to get back to and see if we can get more precise estimates from that. But and anything involving the post-79 period, I think if you're interested in measuring atmospheric warming, the default assumption should be to use the satellite record and the weather balloon record. There you got two independent measurements, and see how they compare, and use some kind of composite between them. But also, since 2003, there's the Argo float data from the oceans. I don't know what to make of the ocean record before that. The sea surface record, I mean, obviously there's no urban heat island effect there, but there's other problems just with the changes in the measuring systems and the fact that you're really only sampling shipping lanes. And people need to understand that for the 20th century as a whole, there's temperature data for less than 50% of the Earth's surface. And a lot of stuff is just being filled in with assumptions or modeling work. So it's sort of the output of models. And so as you go back in time, back to the 1920s, for instance, here in Southern Ontario, we have great temperature records back to the 1920s. Here in Guelph, we have temperature data that goes back to the late 1800s. And one of the things I have my students do, one of their first assignments in my environmental economics courses is just take a few locations in Ontario that have more than 100 years of temperature data and plot the records for average daily highs back 100 years or more. And that one always surprises them, because they just don't see what they're expecting to see in terms of an upward trend. There's a visible trend up to the 1930s or so, and then after that it's kind of up and down and flat. Especially summertime temperatures just haven't really changed much since the 1930s. Gone down, they've gone up. But so but we happen to be in a part of the world where we've got those kinds of long temperature records. Vast majority of the world, there's just no data at all, or there are short temperature records or fragments of temperature records over various intervals. And what we see is these temperature graphs going back to the 1860s that they call the observational record. There's just so many problems with those records. And unfortunately, a lot of the problems are of the form that introduces an upward bias in the trend, and it's very difficult to measure it and remove it. So I did some work on that. I hope eventually to go and do some more. I wish more people took an interest in that kind of topic, though.
Have you followed the work much of Tony Heller when he's looking back at adjustments to cool the past? Seems pretty interesting.
Yeah, and I've seen many of his videos, and now he's focusing on the U.S. record in a lot of his videos. And there, I think the point he conveys, it's frustrating for an observer, is just this notion that, okay, you've got the raw temperature observations and then the adjustments, and they all seem to pivot around 1960, so that anything prior to 1960, the adjustment goes down. Anything after 1960, the adjustment goes up. And they create this picture that somehow in 1960, everyone in the US knew how to measure temperature perfectly. So that's the year we're going to leave it as is. And prior to that, everybody made the same mistake. Everybody was always overestimating temperature. So we've got to adjust those ones downward. And ever since 1960, people haven't known how to measure temperature. We have to raise those measurements. And the pattern of adjustment is so consistent in so many places in the US record that at a certain point, it's just prima facie implausible that that these adjustments are based on some objective algorithm. I know that the people who make the adjustments will say, "Oh well, we've got to deal with time of observation bias, and this and that." And But if these were sort of standard measurement errors, you would expect a mix of positive and negative measure. And there's such a pattern to it, and the adjustments account for all the warming. That's the other thing, that when you look at the post 1960 US record, the adjustments are as large as the warming itself. So for that reason, since the warming trend is such an important input into thinking about the policy, we really need to have absolute confidence in these adjustment processes. But the people who make the adjustments, instead of, I guess, responding in a constructive and forthright fashion to these kinds of criticisms, in my experience, they take such offense that anyone would question what they're doing, and they respond with abuse and indignation when I think perfectly reasonable questions get put to them. And that's another thing that makes it frustrating as an outside observer looking at these adjusted data sets. So Tony does a very effective job in letting people see, okay, this is a graph you were shown. This is what the data looked like when they first collected it, and this is what the observers wrote down, and this is what it looks like after the adjustment process. And again, this whole warming trend in the US record is coming through the adjustments. So we have a right to a very detailed and skeptical review of these adjustments. And the lack of constructive engagement on a question like that, at a certain point, I think, all right, the burden of proof here is on you guys. It's not on the people who look at the data for us to go into every station record and prove it's wrong. The burden of proof here is on the people making the adjustments. For a long time, they would refer back to a paper that was done in the 1980s for the Department of Energy by Tom Wigley as the scientific basis of the adjustments. And when I eventually got a hold of that document, because it's hard to find, it was really just a lot of, okay, this record here, we think it moved around 1925. They moved the station here and there. So we're going to, make a little few changes here, and we'll bump this stretch of the data set up by this amount. And so it wasn't like a detailed scientific methodology that you could subject to some testing and validation. It was really, and for the time, it was all anyone really would have expected, which was go through the data set and discuss the potential flaws and what the ad hoc adjustments were. But for a long time, that was it as far as documenting the adjustments. Now, I think they've got more information out online to help people understand it. But anyway, a long answer to your question. I go back to this question of the adjustment really matters for the overall conclusion. And so if we're going to accept the conclusion, we need to have absolute confidence in these adjustments. And the people who could have, over the years, helped us gain that kind of confidence haven't done so. They've done the opposite. They've been so resistant to any questioning of their work, and made it so difficult for people to critique it. And my own experience, as I mentioned, when you do get stuff into print and journals, then the IPCC misrepresents it and even makes up stuff that isn't true. So I'm quite sympathetic if people just want to dismiss the adjusted temperature record as being the product of a process where people put their thumb on the scale to get a certain result.
What do you think? You have any predictions on where climate science is going in the next 10 or 20 years? Just more of the same, or is it eventually going to crumble? It just seems like this can't keep going on, that the lies are so big that it can't keep going on. But what do you think?
All right. So my observation is that like 20 years ago when I started, if you think of where people are on the spectrum, we've got someone like me, and I would say I don't know what the opposite of the word alarmist would be, but I'm not particularly worried about climate change. I think the evidence is it's not a big deal, and there'll be changes and things to adapt to, but they're on a small scale compared to the normal course of events and things that we adapt to in life. And then you've got the alarmists who are, throwing cans of soup at paintings and gluing themselves to the sidewalk and having a complete emotional meltdown. In the early days, the IPCC was sort of over on the alarmist camp, over against the skeptics, in the sense that they were the ones trying to pull everybody away from a viewpoint like the one I hold and say, no, you guys got to be worried about this. Look at these charts. Look at this. We got to be worried about this. Well, the alarmist side has moved so far up the scale now that I think the IPCC is coming to terms with the fact that they have to begin to pull everybody back in, my direction, our direction, because and they're not good at that. So they're in the position, for instance, with discussions around hurricanes, for instance. You'll get everybody from President Biden on down to some local weathercaster on the Channel 6 nightly news confidently declaring that your tailpipe emissions caused Hurricane Ian, and it's your fault that all those homes were blown down. And you got the experts at places like NOAA and the IPCC thinking, oh, we just put out a report that doesn't say that in fact says the opposite, says we don't want to draw that connection, and we can't see a trend that would be consistent with that story, and all the other things that they say, but they say it in a very quiet, heavily couched language. For a long, they were happy to intervene early on when it was trying to fact check or counter messages from skeptics who were saying, look, this isn't a big deal. They were happy to jump up and tell world leaders, no, don't listen to those guys. We'll tell you this is a big problem, blah, blah, blah. Now they've got an even bigger problem, which is these crazy extremists saying all kinds of stuff that isn't true and isn't in their reports. And what they should be doing is jumping up and saying to world leaders, yeah, don't listen to those guys. They're nuts. We disavow that message. They're not doing that. And I don't think at this point that they're yet capable of doing that. Culturally within that, and I say the IPCC, I mean here, I guess, just the mainstream various branches. There's the climate modeling groups, and then there are the atmospheric science groups and oceanography groups, and people that are all sort of comfortable with each other in terms of an overall set of assumptions. They may disagree on all kinds of other things, but culturally they're comfortable with each other. And I think they're all kind of looking at each other now and saying, well, somebody's got to stand up here and say that's not actually what we are arguing. But nobody wants to do that. Nobody wants to be the one. Well, actually, take that back. You got someone like Roger Pielke Jr., who says, okay, I'll do it. I'll stand up and debunk some of the nonsense around hurricanes and extreme weather. And then what happens? They discover they've got so many extremists and activists in their own ranks who then attack a guy like Roger Pielke Jr. And that sends a message to the whole rest of the climate community. Don't be like Roger Pielke Jr., or you won't get to eat lunch with the cool kids either. And so they've got this police network now in the climate field who make it impossible for them to stand up and distance the field from the kooky extremists. It's going to take a long time for that to get sorted out, but I think there's a few milestones that are coming up quickly. So one is 2030. 2030 will be an interesting year because, first of all, there will not have been any major reductions in CO2 emissions between now and 2030. Well, there will be some this year. Well, there was the COVID recession, but things quickly returned to trend. There'll be this year's winter in Europe where their CO2 emissions will go way down because they're all going to freeze to death because of their stupid policy decisions that have left them without a reliable energy supply. But any emission reductions taking place in the West, and they're small and sporadic, are more than offset by emission increases in China and India and places like that. As industry just leaves the crazy places like Europe and Canada, unfortunately, places where energy is being made prohibitively expensive, heavy industry is just packing up and moving somewhere else. So by 2030, we won't have done the emission reductions that the extreme alarmists have been calling for. But at the same time, we won't have experienced the climate changes that they've been warning about. And all this language that came out a couple of years ago, but we have until 2030 to prevent extreme climate damages and the apocalyptic vision that they created. We're going to get to 2030 and people will have seen the price that they paid for climate policy. They will have experienced the harm. They will have experienced these winters that we're in for, or the Europeans especially are in for, the next couple of winters where they don't have enough fossil energy sources to get through. And everything, just the cost of living effects of climate policy. And 2030 will come and we won't have experienced climate Armageddon. And they won't be able to turn around and say, well, yeah, but we avoided it because we cut emissions, because we won't have cut emissions either. And so that's where I would hope there'll be a certain reckoning, and maybe some of it will have happened up to that point. But heading to that point, we still have the problem that there are lots of people that see this narrative as unsustainable. This whole ESG movement, the climate alarmist movement, it isn't sustainable. It doesn't make sense. But when someone stands up like Stuart Kirk, that guy at HSBC, who stood up, and even though he thought he had approval from his higher ups to stand up and make a speech at a finance conference that said, the climate policy stuff here is none of us really believe in climate alarmism. And he had this great line about the previous speaker said, you're something to the effect of by 2030, you're all going to die from climate extremes and none of you even looked up from your phones. And so you don't believe it. I don't believe it. Our clients don't believe it. And he got sacked. So we're still at the point where the sensible people, and there are fortunately still many of them, the sensible people in positions of influence, they don't yet know how to talk about this, and they don't yet know how to pull the discussion back onto sensible grounds. And again, I'll return to the point I was making at the beginning about the IPCC. They were supposed to be the objective scientific thinkers who just call it straight. And I think they found it easy in the early days when they felt like their job was to up the level of alarm compared to what the general public felt. Well, now the public has leapfrogged them and they're all falling for these crazy alarmist extremes. Well, it's the IPCC's job to fix that. But culturally within the IPCC and the climate science movement, I don't think they're able to do it. And the few people who try seem to get their heads bitten off. So if they can't, then it will also eventually come back on the IPCC. That it'll be a matter of when it becomes clear that the alarmist message was way over the top. People will be entitled at that point to say, well, this is your job to put the brakes on this and straighten people out, and you didn't do it. So how can we trust you now?
Are there any other points you'd like to make?
A point that is sort of a theme to a lot of the stuff I've done on the climate science side is, why would an economist presume to talk about these things? In the process of my undergraduate and graduate education, I took 10 courses in statistical theory and applied statistics. And that again is sort of par for the course for someone working as an applied economist. It doesn't qualify me, for instance, to be a specialist in advanced econometrics, for instance. That's just entry-level qualifications for the field. In the physical sciences, people will maybe do 2 courses in statistics, sometimes an extra course in statistics, but their training in statistics is minimal. And climate science is a lot like economics in terms of the tools that people use. To a large extent, it's applied statistical analysis. And yes, you have to know where your data comes from and you have to be able to interpret it, but the techniques are applied statistics. And a lot of those techniques came out of econometrics, or at least they came out of the same sources, but a lot of the development of the technique has been in econometrics. The paper that I published in 2021, critiquing the optimal fingerprinting method, for instance, that's an econometrics paper. A challenge in getting a paper like that published is that material would be basic in an econometrics journal, but it's very hard for people in the climate field to follow those discussions because it's econometrics, it's econometric theory. I teach econometrics at the 3rd year level, and so I was just going through stuff I would expect my undergrads, maybe the 4th year students, to understand. But for a lot of people in the climate field, this is the first time anyone's really critiqued the theory behind that method, or at least there are people who critique bits and pieces of it. But in effect, I was looking at that and saying, you guys invoked what's called the Gauss-Markov theorem, which is elementary in econometrics. I taught it last week to a 3rd year class. It's Gauss-Markov theorem is just part of the entry-level curriculum. You guys invoked it, but you got it wrong. You left out an important condition. Your method doesn't satisfy the Gauss-Markov theorem. It fails it. That means your claims about providing valid results are unfounded. Test statistic you proposed doesn't make sense. Nobody uses that test statistic in any field other than optimal fingerprinting. Nobody would use a statistic like that because nobody knows what it measures or what it means. So it's kind of a question Steve and I asked with the paleoclimate stuff. Like, why are we doing this? Why wasn't it people in the field who noticed these flaws in the methods, who dug out the data, figured out the method, and pointed out the obvious flaws in it? And so here I am 20 years after this technique was established. I'm publishing a paper that says your fundamental results are invalid. You invoked a theorem incorrectly, and your method does not generate unbiased and efficient results like you claimed. In fact, it automatically fails the condition. So you don't know anything about what your results are here. And then why am I doing this? And why is it 20 years later? How many people worked in this field and didn't understand some rather obvious flaws in this method? So the question isn't why is an economist weighing in on this, but why didn't people in the field notice these problems? They're the ones pushing the results. Is it really the case that of the however many hundreds of people who've worked on optimal fingerprinting papers over the past few years, none of them noticed these flaws? I guess it just means that they're using tools that they don't understand. And if it took a moderately trained economist to come in and point out some obvious flaws in it, then so be it. But the real question isn't, like I say, it's not why is an economist criticizing methodology and climatology? It's why aren't the climatologists noticing problems in their own field?
I was reading an article that mentioned you yesterday, I think, and I think there was a phrase in there about 2,100 expert climate economists. And I just thought that was mind blowing. There's such a thing as a climate economist, and there's 2,100 of them. Does that sound right to you? Like, what would they do all day?
Yes, when I started work in '96, when I graduated for my PhD, there were only a couple of people who did anything to do with climate change. Um, but like any field, there's a lot of money pumped into climate institutes and into universities to study climate change. So it's not a standard field in the sense that trade economics or labor economics or environmental economics would be a standard field. So a lot of people will call themselves climate economists. Now, I see a lot of work. So a popular genre now would be impacts analysis. And this is where people will take climate model outputs at face value, usually the RCP 8.5 scenario, which is garbage, but they'll use it and then they'll look at some aspect of the economy that pineapple growers are going to experience a 5% reduction in output by 2100 because of climate change. And so there's that group, and among that group, kind of like the hockey stick crowd, there was sort of an unstated prize for who can get the flattest handle the farthest back. In the climate economics group, there's an unstated prize for who can come up with the highest social cost of carbon. So can you tweak the models and get a social cost of carbon above $200 and then above $500? And can you get it above $800? And the higher you get it, the more likely your paper is to get into one of the nature journals. And the models that generate social cost of carbon, it's pretty well known how they operate, and there's a few knobs on them. It's pretty easy to adjust them to get really high social cost of carbon numbers. And I've done work on that, and it's also easy to get low social cost of carbon numbers. And then the question is, well, which of these assumptions are more defensible? That's the part where the question typically doesn't get asked. But out of 2,100 climate economists, a lot of them, I think, don't have a big picture approach to the field. Like, they don't necessarily see climate policy as embedded in the whole array of socioeconomic policies, where the ultimate question is what will make people better off on balance, all things considered. Because you can get a lot of these young climate economists who will happily endorse net zero, get them to even sign letters to the European Parliament encouraging them to pursue net zero. And all they've ever studied is what would get us to net zero faster and more effectively. But they don't step back and ask, is net zero a very good target for us to pursue? And is the cure worse than the disease? And what would be a climate policy that we could confidently say would be consistent with making people better off around the world, all things considered, over the next 80 years? There aren't many economists that think about it in that framework. And now one of them who does is a guy like William Nordhaus, who won a Nobel Prize in, what was it, I think 2018, a Nobel Prize for his work in climate economics. And a lot of the activist crowd were jubilant. They say, oh, finally the economists have noticed climate change. And look, William Nordhaus, he's an advocate for carbon taxes. He won the Nobel Prize. They didn't want to mention the fact that his modeling work showed that we should do a bit of mitigation, eliminate some of the lowest value activities that generate greenhouse gas emissions, but otherwise the optimal policy is just to live with it and adapt to it. And that's the upshot of his modeling work. And it's been a very robust result over the 20 or so years that he's been doing this modeling work. And it seemed to convince the profession enough that his papers are in the best journals, and he won a Nobel Prize for it. And yet, like I say, the implications are lost on people, including a lot of people in this climate economics field that you refer to, who somehow think that the fact that William Nordhaus got the Nobel Prize in economics means we should all rush to net zero, even though his own analysis would say absolutely not. That result is not defensible and would make us incomparably worse off. It'd be worse than doing nothing. It'd be worse than just ignoring the climate issue altogether and pursuing economic growth.
I do wonder what percent of the climate economists think that it would be a great thing if we could get back to 280 ppm CO2 and whatever the temperature was in 1850, like end of the little ice age, shorter growing seasons, etc. I wonder if they're actually thinking about that, because that seems completely insane to me as an outsider that we would want that. We'd want to spend trillions of dollars to do that. Totally crazy.
Yeah, and I doubt even the most enthusiastic climate economists, like, and by that I mean the ones who are most worried about climate change and most wanting to push a net zero agenda. I think if you really pin them down on it, very few of them would say, yeah, we should try to reverse engineer the 20th century and get back to 280 parts per million if we could even do it. Mm-hmm. But as to that goal itself, I absolutely agree that if we could go back in time to 1800 or whatever and present people with, okay, here's a future path. One is we don't develop the use of fossil fuels. The economy stays roughly where it is now in terms of living standards, and the atmospheric concentration of CO2 stays at about 280 parts per million, and it remains as cold as it is now. We could do that. Or here's the other path. We develop fossil fuels. We grow our economies by 2100. Basically, everyone around the world is living in a developed economy with a good standard of living. And the atmospheric concentration of CO2 goes up to 500 parts per million, and we get 1.5 degrees or 2 degrees of warming. If you presented that choice to people, the answer would have been obvious. People would have chosen the path that we chose. And halfway along it, no one in their right mind would say, "Oh, let's go back to where we started and not have all these changes." It is literally the biggest no-brainer out there. It was the development of industrial civilization a net benefit to the world? Yes. And the proof of that is that the places where they didn't experience that development are doing everything they can to experience it. And all the supposed harms that people talk about, getting back to extreme weather, which we talked about at the beginning, where are people in the United States moving to? They're all moving to the extreme weather areas. They're moving to the Florida coast and California coast, and they're leaving behind the areas like the Midwest, which have they've 4 seasons, but they're not exactly subject to tornadoes and hurricanes. As soon as they can retire, they leave those places and go to where they'll either have heat waves in the desert or droughts in California or hurricanes on the Florida coast, and that's where they want to retire to. And then when they get there, they can become climate activists and protest greenhouse gases.
Very good stuff. Thank you very much, Ross McKitrick, and we will talk to you later.
Okay, thanks, Tom.
Bye.
Bye-bye.